Now let's solve some polynomial inequalities. This is a little more elaborate because we will have to find test intervals for the polynomial. To determine the intervals on which the values of a polynomial are entirely negative or entirely positive, we use the following steps. First, we find all zeros of the polynomial and arrange them in increasing order. These zeros are called the key numbers. Then we'll use the key numbers to determine its test intervals. Then we choose one x value in each test interval and evaluate it in the polynomial at that value. When the value of the polynomial is negative, the polynomial has negative values for every x value in that interval. When the value of the polynomial is positive, the polynomial has positive values for every value in the interval. So let's go ahead and start this. So first I'm trying to solve when this polynomial is greater than -4. Just like a polynomial equation, we need to get this equal to 0 first. That makes our lives a lot easier. Now we're having 3x cubed minus x squared minus 12x plus 4 is greater than 0. So if we're asking when it's greater than 0, we're asking when is it positive? Okay, keep that in mind. So now we need to find our key numbers. That's when this polynomial equals 0. I find those by factoring. Here I factor by grouping. My GCF here is x squared. My GCF here is -4. So I have x squared times 3x minus 1 minus 4 times 3x minus 1 is greater than 0. My binomial GCF is 3x minus 1. If I factor that out, that leaves x squared minus 4. Now, x squared minus 4 factors to be x plus 2, x minus 2 because it is a difference of squares. So now I'm going to take these three factors to find my key numbers. That's what makes my polynomial equal to 0, and we'll use the zero product property for that. 3x minus 1 equals 0 when x equals 1/3. X plus 2 equals 0 when x equals -2. X minus 2 equals 0 when x equals 2. So these are our three key numbers. Now in order to do this, I like to arrange them on a number line. I'm going to make this long just so I have space. Okay, so -2 is first, and then 1/3, and then 2. And we know at each of these values our function is 0. Our polynomial is 0. So now in this interval here, from -infinity to -2, I could pick an x value, let x equal -3, for instance. You can pick whatever x value you like as long as it is less than -2. So I'm going to plug that into my original polynomial, which I'm trying to make greater than 0. So remember, you can plug this straight into your calculator and you should get -50. So that means in this interval, my polynomial is negative. Or you can put the negative symbol if you prefer instead of words. In this interval, I can let x equal 0. You could pick whatever you like, right? As long as it falls between -2 and 1/3. So now I have -3 times 0 cubed minus 0 squared minus 12 times 0 plus 4. And that equals 4. So that means my polynomial is positive here. Between 1/3 and 2, I'm going to pick x equals 1. You can pick whatever you like as long as it's there. I'm sorry, it's not -3 here, it's +3. But the answer is still 4 on that. So now I have 3 times 1 cubed minus 1 squared minus 12 times 1 plus 4. And so that is going to equal -6. So that means that my polynomial is negative here. And then in this last interval, I'm going to pick x equals 3. You can pick whatever you like as long as it's greater than 2. So remember, I'm going to pull this down. This is 3 times 3 squared, or cubed, minus 3 squared, minus 12 times 3, plus 4. And let me see what that is. That is 40. So that means in this interval, my polynomial is positive. So remember, since we're looking for when our polynomial was greater than 0, we were trying to see when is it positive. And that is when x is between -2 and 1/3, and when x is greater than 2. Now in interval notation, that would be -2 to 1/3 union 2 to infinity. So either of these are acceptable. I can ask for either inequality or interval notation. So now if I want to graph my solution on a number line, let's see. We want -2, 1/3, and 2. We are going to have parentheses on -2 and 1/3 and shade in between. And then we have parentheses on 2 and go towards infinity. So this is my solution graphed on a number line. So that was long enough. One example is enough for tonight's notes, and we will definitely practice this some more in class.